Well, we're going to coming to the end now of this little chapter section on isosceles and equilateral triangles, and we get to do what we do best, what we love to do best. We love to do best, and that is write proof statements. And so we're going to be applying triangle congruence, and let's see what we have here as we work through our proof statement. We got ACE is equilateral. All right, so if it's equilateral, it's also got to be equiangular, right? In other words, equilateral triangles, all the angle measures are 60 degrees. All right, so ACE, that's this big triangle. And so that tells us then that this angle and this angle and this angle, ACE, are all going to equal 60 degrees, be congruent, equal 60 degrees. And then we've got a bunch of parallel statements here. And it's always helpful to sketch things out, particularly when we have these complicated diagrams, because I got 1, 2, 3, 4. There's actually 5 triangles. Big one, 4 in the middle. 5 triangles in this mess. All right, so segment FB is parallel to EC. So FB is right up here. And EC is this whole line this way. So that's parallel to FB. And FD, which is this little diagonal, is parallel to BC. So that's this segment here. Those two segments are parallel. And BD is parallel to EF. So BD is right here. So we got parallelism here. And this is all parallel. All right, and so from all this, we're going to be trying to prove that FED, that's just a little triangle down here in the bottom left of this diagram, is congruent to BDC, this triangle over here on the bottom right. This is absolutely delightful. All right, well, let's move over here to the next slide and let's see if we can't get our proof statement put together. Well, let's get about doing our proof, what we love so well. And we're trying to prove, again, that triangle FED, that's the triangle in the bottom left-hand corner of this diagram, is congruent to triangle BDC, that's the triangle in the bottom right-hand corner, or right-hand side area of this larger triangle. All right, so let's begin by restating our givens. So we got that triangle ACE is equilateral. And then we got these parallel statements that FB is parallel to EC, segment EC. That segment FD is parallel to segment BC. That segment BD is parallel to segment EF. And that D is the midpoint of EC, which means that ED and DC must be congruent. And all of that is our given. Okay, now, if triangle ACE is in fact equilateral, and we're given that it is, then that's going to tell us that the measure of angle E and the measure of angle C is going to be equal to 60 degrees. And that's because the measure of each angle of an equilateral triangle measures 60 degrees. They're also congruent. Now, if you remember, there was a property, goes like this. If A is equal to B and B is equal to C, then A must equal C. And that's what we call the transitive property. So, if the measure of angle E is equal to 60 and the measure of angle C is equal to 60, then the measure of angle E is going to equal the measure of angle C, and shazam, that's the transitive property. Now, you can also maybe remember in times past we can move from equality statements to congruency statements, or congruency statements to equality statements, either way. So if the measure of angle E is equal to the measure of angle C, well, then the measure of angle E must be congruent to the measure of angle C, and that's because of the definition of congruency. Tell you just got to love this. Okay, well, we got that part done. All right, now, segment ED is congruent to segment DC. And why is that? Well, we've been told that D is the midpoint of EC, and that being the case, then ED is congruent to DC. And why is that true? That's the definition of the midpoint theorem. Okay, so let's see here. Now we're going to start looking at some different angle relationships. And so let's see. Angle CBD. Let's see, CBD, that's that angle there, is congruent to angle BDF, and so BDF, let's see, we can say is right here, BDF, this angle right here, BDF. All right. Now, if FB is parallel to EC, and we were told that right here, FB is parallel to EC, then we can draw that conclusion or that proof that angle CBD is congruent to angle BDF because the transversal is this segment right here, BD, and if I look at that, and here's my parallel line right here, took this line down here, and that looks like alternate interior angles. All right, now let's see, EFD. All right, well, that's this angle right here, EFD. It's also congruent to BDF. Now, why would that be true? All right, well, I've been told that segment EF, that segment right there, is parallel to BD, that segment there. And if I look at this angle relationship and this angle relationship, and if I'm saying that FD is the transversal between those two parallel lines, well, that's also alternate interior angle. So we can say I establish all this congruency that angle CBD is congruent to angle BDF, and that angle EFD is congruent to BDF. That's the alternate interior angles theorem. Now again, if A is equal to B and B is equal to C, then A is equal to C. That's the transitive property. And if that's true, then I can then say that CBD is congruent to EFD because they're both congruent to angle BDF. And we had to use different parallel lines, different transversals, to sketch all that out, but that's true because of the transitive property. So now what have we got here? All right, in triangle EFD, I've got an angle there, and I got an angle there, and I've got a side ED, so angle EFD and angle E from the broader triangle, those two are congruent, and ED is congruent, and that looks like angle, side. So let's check this second triangle. Let's set BDC. What do we got here? Well, I've got an angle here, and I've got an angle here, and I got a line segment there. Angle, side. So you know what? Triangle FED is congruent to triangle BDC. And we finish this thing off because of angle, side. I think I want to do 5 or 6 more of these.